Hi guys, I'm going to conduct an optimization on a heatsink. For learning purposes, I've made this relatively simple SOLIDWORKS model of a heatsink. So, using similar methods from a previous video, I've also conducted a thermal analysis on this model. So, right here I have specified the part to be an aluminum alloy, and I've also applied the thermal loads of 300 watts in the bottom surface, and also a convection coefficient that has an assumption where, aside from the bottom part, the entire top part has a forced airflow convection of 130 of convection coefficient. And after that, I've got a relatively acceptable results from my study, where majority of heat is from the heat source, and most of the heat are being dissipated to 32 degrees once they reach the tip of the fin array. And now we're gonna do an optimization study on this heatsink. So I'm just gonna go to a new study, design study, and hit OK. Now we're in the optimization menu, and you'll notice there are three different options that we could place for we could vary and add data for optimization, and there are variables, constraint, and goals. So right here we're gonna add a variable for our site, and we're just gonna name this as site. Site. And we're gonna add another dimension, whereas it's from this height, and we're gonna name that as height. Another thing to note about is that sometimes this when we perform a variable selection with model dimension, sometimes the dimension itself would not appear on our model. So in order to avert that value, sometimes it's always preferable to just click on the extrusion where your dimension will appear. For example, if we're extruding from a sketch from the bottom plane, and we'll usually, if you double click the box extrude feature, the dimension for the height of the extrusion in the extrude feature will show up on the model, and from there you could select the height feature that I just selected for our variable parameters. So right now, after selecting those two dimensions that I would like to vary for this model, I'll hit OK. And from here I'll just add the corresponding dimensions that I've just selected. So I've only picked one side of the instead of the other from this model. It's just to simplify our optimization and analysis. So right here we could vary this, and I'm gonna vary it to range. And range step is essentially that it's gonna vary from, like, for example, if it's 25 millimeters to 2075, it's gonna keep stepping up by 25 each step. So in this situation, it will step up by 3 times to get to 75 for different optimization, and that will come out in different scenarios. Right now I'm just gonna select range, and I'm gonna tweak this to 100 millimeter, and from the side I'm gonna extend this to 200 millimeters. Now I'm gonna add materials. So first of all, I'm gonna name my add a naming parameter for my material, and I'm gonna put this as aluminum 1. I'm just gonna hit OK. Alright, right now I've selected all my 3 different kind of aluminum material for and specify over here, SOLIDWORKS will most likely choose any one of this material for this design, as since all 3 of this material has a specific thermal conductivity, and SOLIDWORKS will help us optimize for the best one in the 3 of them. So those are all my variable parameters, and now I'm going to add the constraints. And one of the constraints I would like to add is our thermal data. So we're going to go to simulation data, thermal. I'm going to change this to Celsius. And over here, instead of model max, we're going to go for max over selected entities. This will enable us to select one of the surfaces that we would like to examine for a maximum temperature on that area, and I would like to optimize for the highest temperature in our model, which is the bottom area where the heat source is coming from. I'm gonna hit OK. Right here, we'll see that our constraint value, given that thermal 1 is greater than, I would like to have it as less than, and I'll specify this temperature as 40 degrees. Thermal 1 right here is our parameter name, but the thermal 1 right here is actually our study for thermal 1 that is listed right beneath under here, in the tab right here. I'll only be setting a very simple constraint right here for simplicity, and now I'm just gonna add a goal for our optimization, and I would like to minimize our entire volume of our model, and we'll just hit OK. And be sure to check that if this is actually minimized. Now that all is done, we'll be running the optimization, and we'll just hit run right over here. And SOLIDWORKS will now change the variable parameter while maintaining the constraint, and we'll try to find a minimum volume for our optimization problem. Okay, now that our optimization is done, what we see here in our given model is actually our optimized model where it fulfills our constraint and our goals. So when we take a look at our data below, we could see that our constraint that's less than 40 degrees, some of our scenarios have actually violated those constraints, and those are listed in a darker contrast red in color, where scenario 1 is 69 degrees and scenario 2 is 54 degrees. And the green section right here is actually the optimal value, which is the model we were seeing right here, and this is pretty much what SOLIDWORKS is telling us to choose. But however, if we look at the goals we have, which is the volume, where we want to minimize them, when we compare with the optimal with scenario 1, well, technically we would like to compare optimal with the with this different scenario, like scenario 6, scenario 7. Scenario 6, scenario 7, and like pretty much anything back here, they do fulfill the constraint that we have, which is less than 40 degrees. However, they have some of the higher amount of volume which we would not want, and SOLIDWORKS is helping us to figure out which is the best to find the lowest amount of volume while making a constraint of less than 40 degrees, and SOLIDWORKS has chosen this parameters for us. Also, take a look at the variable of materials that we have picked. Right here, you can see that SOLIDWORKS has already chosen 1060 aluminum alloy for us. What does that tell us? That is that 1060 aluminum alloys is actually has a better heat conductivity and better heating properties compared to the other 2 alloys that we've chosen to we've put it into the pool for SOLIDWORKS to choose for us. Going back to results view, we could see that our height and side, dimension and side dimension has also been changed to get apparently SOLIDWORKS has chosen a lower height and a great amount of side for a great minimizing volume in our model. So this is essentially how a basic overview of SOLIDWORKS optimizing for thermal issue is being performed. That is all I have for this video, and thank you for watching.